And here we go. What's up? It's still me. Hi, hello. And this one is all about them congruent triangles. And we're going to talk about the four postulates. I mean, three, one theorem. Am I correct? I don't know. But we're going to talk about triangle congruence, identifying congruence between two triangles, what makes them congruent, what postulate or theorem that we need in order to prove that they're congruent. And of course, we're going to start with proving using a two-column proof. And that will be it. Let's just jump right into it. Now we will be talking about congruent triangles, different postulates and theorems at the same time, how to identify corresponding parts, and later on we're going to prove statements involving triangle congruence. So triangle congruence basically takes place when you have two triangles that are congruent if their corresponding parts are congruent. Now here's the thing. When we say corresponding parts, there are two parts that we have to talk about. The first one being the sides followed by the angles. One of the important things that you have to take note, especially with this image that you're seeing on your screens, is that we have the lines right here, and they're actually what we call as tick marks. Tick marks. So the tick marks here basically implies the concept of congruent sides. That's why they are put in that situation or in that location. In this case, if you take note of it, you can notice that this one has one, this one has one also. This means that with these two triangles, we can say that side AC, for example, is congruent to side DF because of the tick marks alone. If you follow this concept, the one with two tick marks would be AB, that side right there, and that will be congruent to side DE because they both have two tick marks. And lastly, you will have BC that will be congruent to EF because again, they're the ones with the same number of tick marks. If you follow this concept, we will be able to apply it also for angles. So not only do we have tick marks, we also have the concept of curves. So the curves now are basically talking about congruent angles. In this example, it's much better that we use three letters so that it will not be difficult for us to talk about it. Let's say that we have angle DEF. This angle is the one formed in E because that's the middle letter. So in this case, it should be the angle formed at B. So that should be the middle letter for this one. So angle DEF should be congruent to angle ABC. So if you follow this, you can also have angle EFD, and that should be congruent to angle BCA. And lastly, you could have angle, what's the next one? EFD, so FDE. Okay, FDE congruent to CAB. Am I correct with that? Yeah. So that's how it works. So in this case, again, the tick marks congruent sides, the curves congruent angles. So we can say that two figures are congruent when the angles and the sides, the pairings of them, are all congruent. But in the case of triangle congruence, we don't have to check all of the details. There are certain postulates and theorems where if these certain situations are already true, are already congruent, we don't have to look for the rest. That one in particular that we're going to talk about is what we call as SSS postulate. The word or the term that the S stands for here is simple. The S stands for side. So basically SSS means side, side, side postulate, meaning the pairs of sides of these two triangles must be congruent, the pairings of them. So AC should be congruent to DF. And again, AC should be congruent to DF. Next, AB should be congruent to DE, and lastly, wait, that's the last one. AC, AB, so BC. So BC should be congruent to EF. It's by side, side, side. The reason why we don't have to look for other details, it's an important note also. One of the, what do you call this? One of the relationships in a triangle where the angles and the sides correspond to one another. Since this one tick mark is opposite to this angle, the AC is opposite to B, and DEF is opposite to E. This means that they have the same relationship. B should be also congruent to E. It's a certain thing that we will have a much more focus on once we go with triangle inequalities. But the concept basically is that the reason why we only need SSS is because the angles corresponding to each side is also corresponding to the angles corresponding to each side for the other triangle. So that's why side, side, side. Next, SAS is not that complicated, but there is a restriction. As you can notice, the A is in the middle. The A stands for angle. So we have side, angle, side. So in this case again, we will have, let's say, AC. That should be congruent to DF. The angle per se, let's say we have angle cab, should be congruent to angle FDE. And then for the last side, we can say side AB should be congruent to side DE. So the important detail here is that the angle is in between. So there are two possible interpretations of this or explanation. The basic explanation is this one. When you have tick marks, SAS takes place when the angle is in between in terms of markings. Now, if it's in terms of the mathematical concept of it, it's basically the angle formed by the two sides when they're connected. Okay, so angle A is the angle formed by the sides AC and AB. Angle D is the angle formed by sides FD and ED. That's an important detail to take note of. Okay, and we can take note of SAS postulate being true if and only if the angle is the one included or in the middle. Again, they use different terms here, either included or in between. You can use those terminologies. Somebody wants to say hi. Go, Evie. Okay. The cat wants to jump. Anyway, next, we also have what we call as ASA, like some of you guys are. Just kidding. This one is pretty simple. I'm sorry, I don't have the time. I'm so sorry, guys. I'm so sleepy. But basically, again, here, we have the angle, side, angle. The side is included or in between. We can notice that already in terms of the symbols. So that's by ASA. Now, if you're tired like me, what you can do as a way for you to identify it without memorizing the names of the postulates and theorems, go to the given. If there's no labeling, or when there's label already, just put the letters. So there's an angle in C, there's a side here in BC, there's an angle in B. So it's ASA already. Take note also on the other triangle, ESA. So it's a technique that I do so that I don't get confused when identifying what postulate or theorem I have to use. And it works all the time. As long as you have an idea of what the four things are that we have discussed so far. Now, the last one that we're going to focus on is the AAS one. So basically, the difference between AAS, this one is the theorem. A short explanation as to why this is not a postulate is because the AA, if you take note of it, is more focused with similarity. So you have to prove that when you have a certain side also, they should be congruent, the pairings of them. I don't know if that makes sense. I'm sorry, my allergies are killing me right now. But again, the difference between ASA and AAS is that the side is set aside. It's not in between the pairs of angles. That's the difference. As you can take note, earlier the side is in between the two symbols. Here, no, it's outside of them. That's how it is different from ASA. Next, if we try to look at images like this, this is by ASA, as I've indicated, there's an angle here, the side in between connecting the two angles. Same case with the other triangle. And if you go to the other examples, this one right here is SAS because the angle is included. You have markings for sides. It's important that you take note that if you have a curve, that's for angles. If you have a tick mark, that's for sides. Now, this one is AAS because of the thing that I explained earlier. This side right here, formed in EF, corresponds to the angle formed in G. Same case with QR, it corresponds to the angle formed in P. So, since EF and QR are congruent, the angles opposite to them should also be congruent. Hence, AAS. So this is another detail that you could take note of. And this one right here is by SSS. Now, here's one thing I have noticed also with some of my students. When the markings are all tick marks, you don't have to think of other things already. That's why it's important that you write on it. Because you don't have to overthink things. As long as you remember, curves are for angles, lines are for segments. That's why there's tick marks. It's not curves, so it's automatically SSS. There's no shame on writing notes on the examples, because if you try to, force yourself to remember what they are, you might get confused. But as long as there are no angles mentioned, automatic SSS. Okay? That's an important thing to take note of and remember. So now let's try to figure out what if we have examples such as this one right here. You have here two triangles, DOG and BAT. So in this case, we have the triangles dog and bat. So let's say that they are congruent. So let's say that dog and bat are congruent. Excuse me. I cannot edit that out anymore. I'm so sorry. I'm so sleepy, to be honest. It's 11:11 already. This will probably be uploaded by like early in the morning. Anyway, you have here first detail that we have DO because of the one tick mark. So the DO should be congruent to the BA. Next, we have DOG and the AT. They're also congruent in terms of sides. And lastly, in terms of angles, we have the angle formed in O and the angle formed in A. So they can simply say that we have angle DOG since it's formed in O, and it's congruent with angle BAT since it's formed in A. So here it's not difficult. Again, just write on it. You have side, angle, side. Side, angle, side. So this is by SAS postulate. That's how it works. You don't have to overcomplicate things all the time. I think we have another example. This one I like. So here you have two triangles formed thanks to having one big triangle. So they are divided into two equal parts here. An important detail here is that we're going to exercise the concept of what we call as the reflexive property. This triangle here could be divided into two pieces. Now let me try to work that one out. Where can I draw it? Okay, I'll draw here. Okay. Say 45. Okay, this is not gonna be perfect. Please don't hate me. Okay, 45. Let's go with a straight one. Wow, would you look at that? So what I'm trying to do here is to show to everybody how these two triangles look like once they are separated. Because we are bitter, we want to separate them. Dapat lahat tayo single. Joke. So this is CPR. I'm gonna need that CPR. And then KP. Oh my god, why am I joking like that? Please don't cancel me. Anyway, so here we go. Oh my god, this is why I don't want to record videos when I'm sick. I'm just sick and tired of cats. Just kidding, I love my cats. They're giving me allergies though. I'm having an asthma attack. I know. What do you call this one? That's it. I forget. Oh, I forgot. Oh, what? Oh my god. Let's just go. Allergic rhinitis. Yeah, that one. So here, I separated them in particular so you can take note that there's something that they have in common. Unless you are overcomplicating things, you can separate them. Okay? But if your eyes do not deceive you, like you're confident with what it sees, just go with it. Okay? So what am I trying to say here? You have here two triangles. And the first one, let's name it as the triangle CPR, and it's actually congruent to the triangle formed by KPR. We know for a fact that the angles formed in C and K are congruent because of the one tick mark. So let's say angle PCR is congruent to the angle formed in PKR. Now, you might be wondering, sir, why are you using three letters? Why are some angles named in one number, one letter? Why is it important to use three letters? Because there are two angles formed in R, at R. So we have to make sure that we can separate them properly. The first angle that we can name is the angle formed here at, yeah, I don't want to use a ruler anymore. Let's say that the angle formed at PRC, this angle right here. So angle PRC is different from the angle PRK in the context that they are in the separate triangles. Why is my voice different? But that's my point. That's why you have to use three letters. But they're still congruent though, because PR here serves as a bisector. Okay, take note of that. PR serves as an angle bisector. It bisects the angle in R into two equal parts. Hence, the markings of two curves. Now, other than that, you might be thinking, it's AA, sir, right? It's angle, angle. Something's missing. Actually, it's there. And the other thing that's actually congruent in this given example is in the image itself and the original one. Or if you're confused with that, you may look at the separated version that we have. So they share PR. They both have PR. That means something simple. And that's what we call as the reflexive property. PR is congruent to PR. Again, something is congruent to itself. Always remember that. You are you. You are congruent to you. I am I. I am congruent to I. The great teacher is congruent to the great teacher. You know, the homie is congruent to the homie. Remember that. Okay? So nobody could do you but you. Remember that. Why am I so preachy? But that's the point of the reflexive property. Again, we call this as reflexive. So, follow your reflexes. You are you. I am I. And this is by AAS theorem. That's it. Why do I sound so different from in a span of 3 minutes? But that's the point. Reflexive property implies that a side is congruent to itself. This takes place a lot when you have overlapping or connected figures. So let's have one more of those later. But for the meantime, what if we have something like this? We have a triangle that is fly. This is the triangle fly and the triangle G and Y. So as you can notice here, let's take note of them. Let's say again that they are congruent. But what are the things that we have to take note of? First, we have the angle formed in L and M. So angle phi is congruent to angle G and Y. Next, we also have the detail that LY is congruent to NY because of the tick marks. So LY is congruent to NY. One more thing here, you might be thinking, sir, what else is congruent there? This is one thing that we have mentioned actually in our previous lesson in terms of parallel lines and a transversal. But this one takes place with any intersecting segments or lines. LG, the entire thing of it, and FN, they intersect at Y, hence forming what we call as vertical angles. So please take note that the angle FYL is congruent to angle GYN because they are vertical angles. Vertical angles are formed when you have intersecting lines or segments. Okay, they're vertical angles. So this one is angle side angle. So this is by ASA. This is by you guys. ASA. Okay, my corny jokes are running out. Let's have one more. This one is like earlier, but you don't have to overcomplicate it. Let's say that we have triangle ADC is congruent to triangle ABC. So we have AD congruent to AB. We have DC congruent to BC. And lastly, again, they share AC. They share aircon. So this is by reflexive. And everything here that we're dealing with are sides. So this is SSS postulate. Okay, we don't have to dwell much on it, we don't have to overcomplicate it. If you want to separate the figures, go ahead and separate them. Now, what if we start with proving? So let's go with some examples. In terms of overlapping figures, let's have this example right here. So again, just like last time, we are given with two statements. Given that AB is congruent to AD and angle 1 is congruent to angle 2, that's where we will always start with. So let's just write it out. AB is congruent to AD. These are the segments. It's here. This is AB. This is AD. They are congruent. And at the same time, angle 1 is congruent to angle 2. This is the given. I want you guys to always remember that. So this is crossed out, this is crossed out, this is crossed out. Next. The next thing that you can take note of, since they are connected, is that AC is existing for both triangles. So we can say again that AC, that side right there, is congruent to AC by reflexive property. And as you can notice, we can actually already prove it without overcomplicating it. So we just copy the last one here to prove. So triangle ABC is congruent to triangle ADC. And the reason here wouldn't be difficult also. Again, just write on it. So AB is a side, AD is a side, angle 1 and 2 are angles, and then AC is a side. So this is by SAS. As quick as that. Again, you don't have to dwell much on it. Because if you do, it will be difficult for you. So that's the concept of proving triangle congruence. Nothing hard, right? So now let's have another one. So we have this example right here. We already have the given. So simply, let's just write it there. BC is congruent to DC. We also have AC congruent to EC. Now, for you guys to not be confused with this, you may add the markings on the image. So BC, DC, 1 tick mark. AC and EC, let's use 2 tick marks. Now, by vertical angles theorem, we know that's the angle formed here at C. Again, we have to use 3 letters. So we can have angle BCA, that's congruent to angle DCE. And again, just write on it SAS, SAS. So this is by SAS postulate. As easy as that. You don't have to dwell on it, as I said. No need to pressure yourself with that one. Let's have another one. Let's say we have these two triangles right here. They're connected. That's easy na. Again, always remember, we start with the given. So JK is congruent to LK. At the same time, JM is congruent to LM. This is by given. It's easy though. Number 2 is reflexive. But again, let's put markings first. JK, 1 marking. LK, 1 marking. JM, 2 markings. LM, 2 markings. May look like 3, but yeah, it's just 2. Now, reflexive property, we know that KM is the same as KM, because that's the one that they're sharing. So, by reflexive, KM is congruent to KM. And lastly, the proving part, let's put it at the last one. Triangle KJM is congruent to triangle KLM. And this is by SSS postulate. Why? Because everything that we're talking about here are just sides. No angles involved. It's SSS. Okay? Now, the last thing that we're going to talk about in terms of congruent triangles is the concept that what we call CPCTC. So when you're given with two congruent triangles already, it's important to take note that every single thing there must be congruent. Given that triangle ABC and triangle ABD are congruent, everything must be congruent. Okay? So that's the important detail here. So if we continue with this concept, again, CPCTC means corresponding parts of congruent triangles are congruent. Nothing to dwell on with that. Basically, the first thing that we have to remember, prove first that the two triangles are congruent, then everything must be congruent. So this is kind of proving that I want you to see. CPCTC takes place most of the time when you have two triangles that are either overlapping or next to each other. So in this image alone, I'm gonna show you one by one, step by step, how it will look like. Apologies, I downloaded the PDF, so I'm just gonna scroll through the next slides. So here, again, always remember, you may separate the image if you want to, so that you will not be confused. If you want to, you're not required to do so. But always know that you will start with the given. That's your first statement and that's your first reason. Now, if you pay attention, the proving part here is quite different from the previous ones that we did. Again, you're now going to prove parts instead of the triangles themselves. So basically, before you prove the parts, prove the triangles being congruent first. Okay? So basically here, as a spoiler to everybody, most of the time, depending on the example, if you're being asked to prove a certain pair of parts, okay, we know that we're going to put it here, just write CPCTC. That's it. I'm not lying. That's what you have to do. That's where you end, because that's what you're trying to prove. Don't believe me? Let's proceed. So first, we separate the image and we write the given. So as you can notice, they share the same side and it's going to repeat for both triangles. So the first statement again will always be the given. Always start with that. There's nothing to be worried about it. The given is already given. So once you deal with it, you can take note already that they both have the JC. That's what they share. So since JC is congruent to JC, that's by reflexive property. Nothing else to worry about there. We already established that a side or an angle or a figure will always be congruent to itself. And to follow with this one, we already are complete with the details that we need. This is side, side, angle, side. To put it in a much better perspective, this is how it looks like. SAS. So now, as you can notice, in the previous examples, this is where we end. But actually, this is the second to the last. We prove first that they are congruent before writing down what we're being asked to prove. And again, the reason behind that is simply CPCTC. That's how it works. Again, corresponding parts of congruent triangles are congruent. The important part here is congruent triangles. That's why that step 3 is the most important part here. You have to prove first that they are congruent before we say CPCTC. Okay? Let's have one last example. Let's say that we have triangle here and we're given with MY congruent to ON, OY congruent to MN. Now, the difference between this is actually overlapping instead of being connected. So it's a bit difficult compared to the previous ones. So what you have to do here, suggested, separate the images. They're overlapping kasi. So it will look like this. You will see your bias probably in twice. Anyway, just kidding. So you write the given again. That's your first statement and reason. You write it there. Followed by what else you can notice. They overlapped earlier at this part. This is where they share. Momo. So basically, MO is the same as MO, right? Nothing complicated. Reason, reflexive. Now, we have all the parts that we need. There are no angles mentioned. side, side, side. So this is by SSS postulate. So now we have proven that the two triangles are congruent. All we have to do is to write the parts we're being asked to prove by CPCTC. And that's it. That's how CPCTC works. So in summary, what you have to do in order to prove triangle congruence or congruence of parts of two congruent triangles, you have to identify two triangles and parts of it first. Check the segments, check the angles, whatever you need to check. Check the pairings properly. Prove that they are congruent, and then once it's proven that they are congruent either by SSS, SAS, ASA, or AAS, you may now proceed to CPCTC to prove the parts. Now, disclaimer to everybody, these are not all the triangle congruents. There are some more triangle congruents that will be discussed in the future in your classes, especially for right triangles. But in the meantime, these are the four things that we have to focus on. So that's it for triangle congruence. That ends our video about them congruent triangles. Hope you guys already managed to finish all of your requirements. If you're not my student, hopefully you're doing well. To my students, hope you are all not doing well. I'm just kidding. I don't mean that. I hope you guys are doing well, and hope you guys are still safe. Doing good, doing better, or at least getting by. Always remember, everything will be all right in time. As said by Ben and Ben, as they sang it in the song "Leaves." And now I'm leaving you with this. Good morning, good afternoon, good evening, and good night. Before you sleep, remember what's up, and that is respect. This outro doesn't make sense. Bye bye bye. Bye bye bye.